This is the assignment one of advanced machine learning on the topic of handling class imbalance. These are all the contents included: introduction, data loading and pre-processing, model training, evaluation matrix, result comparison, and conclusion. The first content is introduction. Here, in this particular introduction, class imbalance occurs when one class has significantly more samples than others. Here, they are initiating that the class imbalance will occur when one class has different number of samples, like duplicate samples. It leads models to favor the majority class and ignore minority ones, common in domains like fraud detection, medical diagnosis, and anomaly detection. Here, class imbalance are basically occurs in fraud detection and medical diagnosis and anomaly detection. Handling imbalance improves fairness and accuracy of prediction. What's the thing that if we handle this class imbalance data, it improves the fairness and accuracy of the prediction. The next is dataset loading and pre-processing. Used an imbalanced dataset for classification. Here we are using imbalanced dataset. It's a split data into training and testing. The 80% of data will be split into training and 20% is split as testing. Analyzed class distribution to detect imbalance. Here we are analyzing to detect the imbalance. Applied resampling methods like smooth, synthetic minority oversampling technique. We are here in this particular thing, we are using the smooth technique. Normalize features such using standard scalar for better model performance. We are now normalizing the features to better performance. Next will be continued by Zulkar.
Next is model training. We implement logistic regression and random forest models, and we train the models on both imbalanced and balanced data set. And we use smooth and oversample minority classes before training, before retraining. And we compared models' result to observe the effect of balance. Next. And next is evaluation. Accuracy is not reliable for imbalanced dataset. And use precision, recall, and F1 score for better evaluations. ROC, ROC and AUC crew used to analyze overall model discrimination ability and confusion matrix visualized correct and incorrect predictions. So next slide will be continued by Shweb.
Hello everyone, myself Mohit Sudhar. I am from C section AML department and I am here to explain this code. I am continuing this code. So import pandas as PD, a library for data manipulation, and gives it a alias PD. Import numpy as MP, imports numpy used for numerical arrays and operations alias NP. Import matplotlib pplot as PLT, imports plotting functions from the matplotlib alias PLT. From sklearn datasets, import male classification, imports a helper that generates synthetic classification datasets. From sklearn model selection, import train test split, imports functions to split data into training and test sets. From sklearn linear model, import logistic regression, imports the logistic regression classifier. From sklearn metrics, import accuracy score, prediction score, recall score, F1 score, mm, intended to import metrics for evaluation, accuracy, precision, and recall and F1 score. Note the actual code shows a truncated name F1 score that say type it should be F1 score. If not, fix the script will raise the import error. From sklearn sampling imports mode. Import smart synthetic smart is also called as synthetic minority oversampling technique to oversample minority classes. From imlearn undersampling imports imports sampler imports random undersampling to reduce majority class. And next, create imbalanced data set. Connect describing x, y equal to make classification samples equal to 100, uh, n feature equal to 10, weights equal to 0.9, 0.1, and calls make classification to generate features and labels. Parameters used for the visible n sample equal to 1000 means 1000 rows. N feature equal to 10 means 10 features. Weights equal to 0.9 comma 0.1 to make class 0 similar to 90% and class 1 similar to 10% imbalance. X train, X text, Y train, Y test, train test split, XY test size 0.3, random ST, splits X and Y into training and test sets. Test size equal to 0.3 means 30% test, 70% train. The truncate likely contains random state for reproducibility result X train X text, Y train Y test, print original class distribution, PD series Y values counts to dictionaries, creates a pandas series from Y and prints counts per class as a dictionary. And next, train without handling imbalance. Model equal to logistic regression. Instantiation a logistic regression model with default hyperparameters. Model of it X train, Y train trains the logistic regression on the training data. Y prediction model predict X text predicts label for the test set and stores them in Y prediction. Yes. Apply smart. Smart equal to cap smart creates a smart object with default parameters x smart y smart equal to smart fit resamples x train y train applies smart to the training set synthesizes new minority class examples so classes are balanced returns resampled features or labels models mode equal to logistic regression. New logistic regression instances for smart data. models mode dot fit x mode comma y mode uh, trains the model on the smooth balanced training set. Y predictions mode equal to models mode prediction x test predicts predicts the original test set, applying undersampling. Rus equal to random undersampler creates a random undersampler. Xrus, comma virus equal to rus dot fit resamples x train, comma y train applies undersampling, reduces majority classes, explain to balance classes, returns resampled arrays. Model rus equal to logistic regression, new logistic regression instances for undersampled data. Model res.fit xres yres train model to undersampled training data. Y prediction res model res predicts x test predicts on original test set. Plot result methods equal to originals mode undersampling labels for the bars in the plot. Accuracy equal to accuracy score y test y prediction accuracy score y test y predictions mode. Starts building a list of accurate for the three methods. Um, recall equal to recall score y test y prediction recall score y test y predictions mode. Recall starts list of recall values. PLT figure size equal to 10 comma 4 creates a new figure size 10 into 4 inches. PLT subplot 1 comma 2 comma 1 selects left subplot 1 row 2 columns first plot. PLT bar methods accuracy color red green blue plots a chart of accurates for each methods with specified colors. PLT title accuracy comparison title for the subplot. PLT y lim 0 comma 1 sets y axis limits between 0 and 1. PLT subplot 1 comma 2 comma 2 selects right subplot second plot. PLT bar methods recall color equal to red, green, blue. Bar chart of recall values. PLT title recall comparison title for the second subplot. PLT y lim 0, comma 1 y axis limits 0 to 1. PLT tight layout adjust subplot spacing to prevent overlap. PLT show renders the plot to screen. Observed printed output for your output run, original class distribution, and confirm 90 or 70 imbalance. Mm. Thank you, everyone.